Today we will discuss three-phase half and full wave uncontrolled rectifier. Today we will see a simple three-phase, a common cathode configuration. If you see, we have connected all the cathode are connected together. So this is called the common cathode, which is connected to the load. Now I have applied a magnitude of 5 volt, 10 volt, minus 5 volt. So out of these three diode, which diode will conduct? The diode which is having higher potential, that will conduct. That means D2 will conduct. So because the D2 is having higher anode potential. So this is called, this is a common cathode. We will see a common anode configuration. The anodes are connected to the common bus, or all the potential in the anode are the same always. And which diode will conduct? If I will ask you which diode will conduct, because the diode which is having lowest potential or lowest voltage, that will conduct. This T2 will conduct. Now similarly, I have n phase, and this n number of phase and it is depicted here. That this voltage, that V1, V2, V3, V4, there are different type of voltages, and which are applied here, and the diode will conduct according to the higher potential at the anode voltage, because it is a common cathode configuration. So we have seen that D2 conducted in the common cathode because the potential at anode potential in the D2 is the high. So similarly, we have V1, V2, V3 up to V4, and this V4, whichever the highest potential, that will conduct. For example, V1. So first one, you can see that V3 is here. So V3 will conduct, this is positive up to this point. At this point, you will see that the voltage V4 is high. So the V4 start conducting this one up to this point, and then V2 or the V2 is high, so D2 will conduct, and this after this, then you will see that this is again V. The V naught is the solid. This is our V naught, and you can see that this is your output voltage. Similarly, we will see a three-phase half control rectifier. So we are having D1, D2, D3. This is also a common anode, common cathode configuration, and we have a V1 which is Vs sin omega t, V2 is Vs sin omega t minus 120, V3 is Vs sin omega t minus 240. So you know that in this one, V1 will conduct during the positive, or because V1 is higher at this point. So during this period, V1 will conduct, and you can see this is our output. And as soon as you will find there is also D2 at this point. So V2 is higher after this is 150 degree. You will see that the V2 will conduct, and this is the D2 will conduct at this point, and then D3 will conduct during this period, and this period D3 will conduct. So you can see that there are three poles in a cycle, and this is called three pulse converter, and you can find out what is the average output voltage V naught is given here, 3 root 3 divided by 2 pi into Vm or Vs. So if we see for a constant current load, we have a constant current load. This is a three-phase VA, VB, VC, and I have a constant current. That means at any time one device must be on, because it is a constant current load. So at this point, if you see here, in the positive, I told you this point is your natural commutation point. After that, VAN is having higher voltage. So during this period, if you see, during this period the D1 conduct. So as a result, this current I0 will be carried out by D1. And at this junction, VB is higher. So VB is higher and VB is conducting, and the load current is carried by D2. And similarly, in this third half or the after this, you can see that the D3 is conducting during this period. As a result, the D3 carries the load current. If we have a capacitive load like this, if you connect a resistive load and a capacitance in the parallel with the resistor, you can see that we have, this is our output voltage, is the output ripples. This is 3 pulse, but due to the capacitance, the voltage will be somewhat like this, okay, like a DC, okay, it will filter out all the ripples in this one. Then we will see a 3-phase full wave rectifier. So 3-phase full wave rectifier is having 6 number of diodes, okay, 1 to 1 DC, D1 to D6, and connecting to a load here. Now diode D1, D2 and D3, okay. So these are the positive group of diode, and negative group of the diode is similarly that 4, 5 and 6. So the positive half is D1, D2, D3, and negative diodes are D4, D5, D6. So if you see here, this positive group of diode we connect together, and negative group of diode we connect together. Why? Because always you can see that in the positive group is nothing but is a common cathode, and which is when there is a higher the input voltage or the anode voltage, that will conduct and connected, and VO1 and VO2 with respect to this ground, and it will conduct, and each diode conduct for 120 degree. Yeah. So if you see here, this here, the T1 conduct during this period, so this positive half appear here, that is VO1, okay, and then the 2 conduct here during this period and gives this peak of the voltage, and during this period D3 conduct, because D3 having higher potential as compared to others, and we get this peak. Similarly, in the negative half cycle, so which one we will conduct first? You say D4 is conducted, you got this negative peak, and D5 is conducted, you got this negative peak, and D6 is conducted, you get this negative peak. So this minus this is your output voltage. So the output voltage, you can see that it is having 6 pulse per cycle. So 6 pulse per cycle it comes, and you can find out the average output voltage from here is nothing but is a 3√3 by pi into Vm or Vs. So if there are inductive, pure inductive load, so if you see that one, you will see here, if your load is very highly inductive, like it is a constant current and ripple free current source, a load, then you can see that this current will be a square, quasi square wave. If you see here, this D1 current will flow here, D2 current will flow here, D3 current will flow here. Similarly, the opposite D1 current here, D4 current here, D2 current and D5 current are here, like this. So the diode conducting D3, D5 like this, and you will see that this is the diode D3, D5, D5, D1, D1, D6, D6, D2, like this the diodes will conduct in the